Okay, so we're doing systems of equations using substitution. So previously we had done systems of equations graphically, but now we're doing substitution method. So substitution is really just we're replacing one piece with something else. That's all that substitution is. It's just replacing. So the first thing we need to do in any problem is we need to find where we have a variable that's already separated. So in these, we're lucky, it's already done for us. We have an x that is already by itself. We're looking for x equals something or y equals something. So we have x equals y plus 6. And so now we have to find where we can substitute this into our second equation. So we're going to also look for an x. Since we know x equals y plus 6, we can substitute y plus 6 in for this x, okay? And so now that brings us, so rewriting our second equation, we have plus y equals 10, right? We just took that from right here. But now instead of an x, we have y plus 6. See what I did? I just replaced x with y plus 6. And then I kept the y equals 10. All that stayed the same. So now for solving this, all we're going to do is combine our like terms. Which is y plus y. So we end up with 2y. The 6 stays the same. Equals 10 stays the same. Now, this is just a two-step equation, which we've done a bunch of. Our first step, subtract 6. 2y stays the same, equals 4. So now we divide by 2. So y equals 2. But it's important to note we're not done yet. We did find y, but we also need to find x, because our solution is going to be of the form x comma y. So we have y, we need to find x now. And so anytime we're finding the second variable, we're always going to use what we circled at the beginning. So if you see I circled y plus 6, so that equals x, so x equals y plus 6. So x equals, we said y is 2, so 2 plus 6, x equals 8. So for problem 1, our solution is 8 comma 2. We took our 8 from here and our 2 from here, and we made it a coordinate point. Now, in part B, we see we have y by itself immediately, and it's set equal to 2x minus 1. And so here, we're substituting y in for this y in the bottom equation. It's important to think about, we're not replacing 3y, we're just replacing y. So we can't forget our 3 when we rewrite the second equation. So here, we're 2x, we're not changing. 2x plus 3, we're not changing that either. The y became 2x minus 1 equals 7, negative 7, stayed the same. So now, to solve this, we first need to distribute. 2x doesn't change, plus 6x minus 3 equals negative 7. Now we have to combine our like terms, which gives us 8x minus 3 equals negative 7. Two-step equation. First, add 3, add 3. I'm going to head over here. So now we got 8x equals negative 4 because we added 3. Now we're dividing by 8. So x equals negative 4/8, or x equals negative 1/2. But we are not done yet because we need to find y. So we know y equals 2x minus 1, y equals 2. We know x is negative 1/2, so we can replace that. Negative 1/2 minus 1. 2 times negative 1/2 is -1 minus 1 is -2 equals y. And so our solution for part B becomes -1/2 -2, which we got from right here and right there. Moving on to problem 2, we have a word problem. So, on Saturday, the vacation resort offers a discount on water sports. Surfing lesson and parasailing is $130. And on that day, 25 people surf and 30 people go parasailing, and they collect $3,650. And we need to find the price of both surfing and parasailing. So, our two activities, surfing and parasailing, are going to be our variables, okay? So we'll call surfing X, and we'll call parasailing Y. And it's important to note that surfing and parasailing costs $130. Okay? So for writing our equation here, the and should be telling us that we are adding the cost of surfing and the cost of parasailing to get to our 130. So X, surfing, plus Y, parasailing, equals 130. So that's our first equation, but we need two since we're doing systems. So our second equation is going to come from 25 people surfing, 30 people parasailing, and a total of $3,650. So because 25 people are surfing, and surfing is X, that's 25X plus 30 people parasailing, which is Y, so 30Y equals the total of $3,650. Okay, so now I would say that this top equation is much easier to solve for either of our variables, because we need a variable that looks like, we need an equation that looks like X equals something or Y equals something. In this equation, all we need to do is subtract the other variable to the other side, and we'll get that. So if we say subtract Y from both sides here, then we end up with X equals 130 minus Y. And now we can use this to substitute. So, substituting 130 for X, our second equation becomes 25 times 130 minus Y plus 30Y equals 3650. So now we have to distribute our 25. So 25 times 130 is 3250 minus Y. 25 times -Y minus 25Y plus 30Y, we just bring down, equals 3650. So now we need to combine our like terms of -25Y and 30Y. And I'm going to do that over here. So we still have 3250 plus 5Y, because we combined our like terms, equals 3650. Now, subtracting 3250 from both sides, because this is just a two-step equation. This cancels. 5Y equals 400. Divide by 5. Y equals 80. Okay, so now we have our Y, but we still need X. But thankfully, we circled what we were going to use to find X right at the beginning. It's right here. X equals 130 minus Y. So X equals 130 minus, we said Y was 80. So 130 minus 80. So X equals 50. And it's important to remember, we're talking about dollars. So this is $50 and $80. And so technically our solution would be 50, 80, but it's asking us for the discounted price of each activity. And so we know 50 is X, which is the price of surfing, and 80 is Y, which is the price of parasailing. So those are our prices. Finally, on problem 3, we're back to just solving. So first, we're going to look for a variable that is already solved for and is by itself. We see in the first one, y is by itself, y equals. So y equals this, which means we're substituting for y. So this y, so all of this is going to go right here. So now, rewriting our top equation, we have x, we just brought that over, plus, now this is where our substitution happens, negative x plus 5 equals negative 4, because we didn't change that. So now, combining our like terms, x, negative x, that becomes 0, so we have 5 equals negative 4. But 5 doesn't equal negative 4, so therefore, there is no solution here. So no solution, graphically, that would be two parallel lines, because a solution is our point of intersection. So if there's no solution, then the lines are parallel because they never can intersect. So this represents two lines that are just running next to each other forever, that will never touch. Now, part B, we see, once again, y is already solved for. It equals negative 2x plus 5. We're going to substitute for the y in the second equation. So now we have to rewrite our second equation. So 2x stays the same, plus, this is what we're replacing, negative 2x plus 5 equals 5, because that didn't change. So now we're combining our like terms, which are going to cancel out because it's negative 2x and 2x. So then we have 5 equals 5, which is true. And so that means that there are infinitely many solutions. Infinitely many solutions. And so if we think about this graphically, infinitely many solutions is going to be two lines that are stacked on top of each other. They're the exact same line. They're intersecting at every single point that they have. So it's two lines that are literally on top of each other, the same line. And that gives us infinite solutions. And that shows up when we have something like 5 equals 5. So anything, a true statement right here. Whereas no solution would be if this is just a false statement. And that's it for today.